Okay, this is chapter 1, chemistry, some basic principles of chem. First question is on empirical formula. The question is cadmium molecule has 58.77% carbon, 13.81% hydrogen, and 27% nitrogen by mass. Find the empirical formula of cadmium molecule. Now, very easy question. First, you find out the mole ratio of all the elements, which is basically the percentage by mass divided by the atomic weight. So for carbon it will be 58.77 by 12, which is 4.9. For hydrogen it will be 13.81 by 1, which is 13.81. For nitrogen it will be 27 by 14, which is 1.9. Now you divide all these mole ratios by the lowest of the mole ratio. So lowest mole ratio will be 1.9. So all of these are divided by 1.9. For carbon you get 4.9 by 1.9 as 2.5. For hydrogen you get 13.81 by 1.9 as 7. And for 1.9 by 1.9 you get 1. So, and that is the ratio in which these elements will be there in the compound cadmium. So cadmium molecule will basically be C2.5, H7N1, which can also be written as C5H14N2, which is the empirical formula. Now we move on to the second question, which is basically the combustion reaction. In the combustion reaction question itself, 10 ml of gaseous hydrocarbon combusts to give 40 ml of carbon dioxide and 50 ml of H2O, vapor H2O. What is the formula of the hydrocarbon? So we know that we can generalize the combustion reaction. We can say that CaHb, that's the hydrocarbon, plus A plus B by 4 of O2 combusts and gives ACO2 and B by 2 H2O. Okay. Now in this reaction we know that 10 ml of hydrocarbon combusts, right? So that's the initial condition, and then in the final condition there's 0 of hydrocarbon left and 10A carbon dioxide because it's ACO2 and 10 into B by 2 H2O, which is 5B of H2O left, right? Because 10 ml of hydrocarbon is used, and obviously O2 is in excess, so yeah. So that means 10A equals 40 40 ml of CO2. That means A equals 4, and 5B equals 50 ml of H2O, which is 5B equals 50, which is B equals 10. So the hydrocarbon we're looking for is C4H10. Now let's move on to the third question. Third question says, an aqueous solution of 6.3 grams oxalic acid dihydrate is made up to 250 ml. The volume of 0.1 normal NaOH required to neutralize 10 ml of this solution is what? So in this question, basically we have to find the equivalence of oxalic acid, right? Neutralizing the equivalence of NaOH. Basically the equivalence of oxalic acid will be equal to the equivalence of NaOH, right? So first we find out the normality of the oxalic acid solution. For this we have to first find the strength, because only so the strength is basically the mass by the volume it is made into, right? 6.3 by 250, which will basically be 25.2 grams per liter. Now normality of this is equal to the strength by the equivalent weight, and the equivalent weight of oxalic acid, now oxalic acid is C2, it's oxalic acid dihydrate, right? So it will be C2H2O4.2H2O. Equivalent weight will be molecular weight by 2 for this compound, which is 63. So strength is so normality is basically 25.2 divided by 63, which is 0.4 normal. Now according to the normal equation, N1V1 equals N2V2, right? And N2 of NaOH is basically 0.1 normal, right? And V1 is 250 ml and N1 is 0.4 norm. So we get V2, which is volume of NaOH required to neutralize, as 40 ml. Yeah, that's the third question done. Now the fourth question is fourth question is that H3PO4 is given and we're given its molarity as 0.3 molar, and we have to find the normality. Now we know that H3PO4 as an acid, the basicity is 2 because P is double bonded to O, single bonded to H, and 2 single bonds to OH, right? That's the compound H3PO4. So basicity is 2, and we know that the equation normality equals molarity into basicity or the acidity. So therefore normality equals 0.6. That was an easy question. And then the last question which I've picked is basically concentration of solution remains independent from temperature. Which of these concentration terms remains independent from temperature? Molality, molarity, normality, or formality. Now in molarity, normality, and formality, volume is used, right? Volume is used to calculate these terms. And we know that volume changes with temperature, so definitely not these. But mass does not change with temperature, and in molality, mass is used to calculate it. So molality does not change with temperature. And one bonus question, let's take. There's an equation given: 3ClO gives ClO3 minus plus 2Cl, all are aqueous. What type of reaction is this? Now, in ClO, chlorine has oxidation state +1, and in ClO3 minus, chlorine has oxidation state +5, and in Cl minus, it's -1. So, chlorine, the same element, becomes oxidized and reduced. That means it's a disproportionation reaction. And we are done. Thank you.